Graham, thank you. So yeah, so I'm Stephen Cook from the Research Software Engineering team at Exeter, and I'll be talking about Vagrant for development environments. It's going to be a bit of live, not live coding, but live interacting with the tool in the session. So I'm going to cover the introduction of what Vagrant is. I'm going to cover creating Vagrant virtual machines or virtual machines using Vagrant. I'm going to cover connecting to them in a few different ways, managing the actual virtual machines, and then a bit about provisioning. So getting software onto the virtual machines at setup so you can reproducibly get the environment that you want to work with. I'm going to show two methods for that with a Vagrant file and Ansible. So what is Vagrant? So Vagrant is a command line tool for creating virtual machines. It works with a virtual machine organizer or a hypervisor. And it self-describes from its website as development environments made easy. Vagrant enables users to create and configure lightweight, reproducible, portable development environments. I've been using it on a project where I wanted a kind of a clean machine to work with the PI on developing a bit of C++ code. So the required software, so you need some sort of piece of software for managing virtual machines. Here I'm going to be using Oracle VM. There are alternatives. There's VMware Fusion, Hyper-V. I am working today on a Windows machine, which actually I think your life will be slightly easier if you use Linux or a Mac for reproducing a lot of this work. The other software that we're going to use for this Vagrant demonstration is Vagrant. Vagrant is from HashiCorp, and here are two links for VirtualBox. That's Oracle VM VirtualBox, and Vagrant Up is the website for Vagrant. Okay. So Vagrant allows you to pull down an image of a virtual machine box for conveniently using. There are many boxes that you can get hosted on vagrantup.com. They officially recommend ones produced by HashiCorp because it's Vagrant HashiCorp. So that they recommend their own boxes, and there's some boxes which are managed by the community under the name Bento boxes. These are managed by Chef, which is a tool for provisioning provisioning machines. There are many others. So the most popular one on there with the most downloads at the moment, I think, is the base Ubuntu box. Bento box will have its own Ubuntu box, which it tries to kind of iron out any potential creases. But yeah, today we are going to be using a Bento box. So first things first, we want to initialize a Vagrant file. So if we go on to so I'm going to be using bento/CentOS 7.9. No real reason for this. It's just one I've worked with before. So this is the Vagrant up for this Bento box, and it recommends a way. So it either provides a default Vagrant file, which we will put in a folder, or we can do it from the command line with the Vagrant tool installed. So I have a directory where I want to install this box. And so I'm just typing in the command from this Vagrant box website, Vagrant init bento/CentOS 7.9. And they're a bit cold in this room. I have put the radiator on, but hopefully I don't fat finger too many commands. What this is doing is this isn't actually fetching the box at the moment. It's just creating a template Vagrant file. So if I look at that Vagrant file that it's just created, So this is so it's actually Ruby that it's using under the hood. So this is Ruby syntax, but you can think of it as a domain-specific language for these vagrant files. And that command that I typed in, it just filled out this template, and the only thing it did is it replaced this line 15 with the name that I just typed in. Within this template, there are a number of other options that can be activated by uncommenting lines. And these are for things such as checking for updates, for opening ports, making ports available to your local host, for synchronizing folders, and for assigning the number of memory or the number of CPUs that are available for this. But for now, so as long as I'm in the directory next to this vagrant file, I can just type vagrant up. The very first time that you call this function, it will go away and it will download the box. I've done this talk earlier today to myself, so it's already downloaded this, so it might take a little bit longer than it's happening now. So, but typically it would download the box and then it would spin it up. And sometimes on Windows it does hang at this last step, but it seems to be fine this time. And as we can see, so this is VirtualBox. This is the actual VM hypervisor that I don't think it's actually a hypervisor, but this is managing the virtual machine. So this has been kicked off by Vagrant. So we can see here I have a running virtual machine here. Okay, so now we are connected. So we can connect through the Oracle VM VirtualBox. So I can just press show, then I get a login screen. The username and password are both vagrant. Okay, so that's one way of connecting into this running virtual machine. Another way that we can, I'm going to make this a bit smaller. So another way we can connect to it is we can locally connect over SSH. Now it's reassign the port from the usual SSH port, which would be 22. It's reassigned just to 2222. So from our window here, we can SSH into it, vagrant at localhost with the port 2222. The first time you run it, it will check that I'm happy happy to connect to for the first time to a new SSH connection. And again, the username was vagrant, the password is vagrant. So now I'm in the VM. And finally, there's a vagrant helper function for connecting, which is just vagrant SSH. And that, again, I can SSH into this virtual machine. So that is the CentOS VM running in my machine. Okay. So the other way that I was connecting to it when I was working on a project recently is I was connecting to it through VS Code. Now I can add the SSH config to my SSH config file with another helper function config. So this generates the SSH configuration that I would use to put into my SSH config, and it tells it where the identity file is, the port and the username that it wants to use. So I can add this to my SSH config file. It gave it the name default. So just to see from here, I can also connect to it by using SSH default. If I go into VS Code there's a Remote Explorer extension. And in here, I can connect to remotes, or I can connect to running containers. So I can connect my VS Code window to the running virtual machine box. And from here, I can also add extensions into this VS Code box. So it'll take a couple of seconds to download the VS Code server and install it, and then I'm good to go. I mean, I have an interactive session inside this box. In terms of extensions, so there are a number of local extensions which are taken from my Windows machine. They can just be running. But anything that actually needs to run on the host machine, or on the server machine, if you like, we have to install separately. So, for example, down here, I might want to install Rainbow CSV to get CSV files showing with rainbow colors, so you can see what's in what column. Okay, so I found that a useful way of working on a recent project. So it was the remote SSH extension. That was the extension that I was using to connect in. And the reason I could connect, that it just found it, was because I'd run this SSH config line prior to that. So yeah, so we've covered connecting and installing extensions. In terms of inside this virtual machine, so we can access any files on our host machine. So if I make a file called hello.txt, so this is just in the file where the vagrant file is. Now, by default, this directory is mapped across onto a directory /vagrant. So I have the hello.txt, and I can also see that vagrant file in there. And if I were to write something into that file there, /vagrant hello.txt, then in here, back in the host machine, these files are synchronized. So I can see that change that I've just made within the VM. So by default, the root directory where the vagrant file is mapped into /vagrant. But you can also, with the vagrant options, you can add more directories that will then be synchronized across. And you can specify where they are on where they will end up on the virtual machine. Okay, so ways of managing this virtual machine. So the vagrant commands that we have, so we can pause the machine. So if we just suspend the machine, that will freeze it, that will take a snapshot of it, and then we can resume it exactly from that point. And so we suspend it, we pause it with vagrant suspend, and then we resume it with the same command we initially launched to create it, which is vagrant up. So it saves the VM state and suspends the execution. You can see that it's got a saved snapshot there. And if we now vagrant up, then it would just resume that VM at the point that we froze it. So if we want to stop it, send the stop signal to that machine and let it gracefully close down, then that'll be vagrant halt, which I'm not going to do here because I still want to use it afterwards. But once you've run vagrant halt, you can completely destroy the virtual machine by running vagrant destroy. Generally, I think it's a good idea to not just have a single virtual machine that you're using for time immemorial. but it would be better to re-provision it quite regularly and get this clean VM each time. In terms of provisioning, so the provisioning which is inside that vagrant file, this normally only happens the first time that it's run. Whereas if you want to rerun the provisioning, you can run vagrant up -- provision. I'm going to talk a bit more about 2 ways of provisioning in a couple of slides. Okay, sharing files to the VM. I've already covered this. This was the this hello.txt, which I put in there. And in this vagrant file, you can synchronize more. So this is a command for synchronizing more folders. So this would just go into this vagrant file. And I think there is an example in here of synchronizing a data file to /vagrant_data. So if I wanted my local data file to go in, I would just uncomment that line. Okay. In terms of provisioning, so provisioning is how we're going to get pieces of software into this, and we could do it from the command line inside, but we'd like to, if we then destroy that, we would then destroy that VM, we would have to repeat those steps. So we'd like to capture that and be able to reproducibly make these with the same sort of setup. So inside this vagrant file, there is, so this template, the default template already comes with an example provisioning. This is for an Ubuntu machine, I believe, if it's using apt-get or at least Debian based, whereas the CentOS, this uses yum. So I would typically do yum install -y vim. So now if I were to reprovision this machine, then it would install Vim through the yum package manager. And let's do that. So first I'm going to halt the machine. I'm going to stop it. And then I'm going to launch it again, but telling it that I want it to provision to add this package in. So I have to vagrant up, and to make sure it provisions, I'm going to add the flag provision. So it does the initial setups of the ports. And then in a second we should see the output of yum installing Vim. So yeah, it's like it's found it. Okay, so yeah, we have installed Vim successfully in in our VM. So if we connect into it with the helper function vagrant SSH, then we have a fully working copy of Vim in there. Perfect. Alternatively, instead of having these inline scripts, we could have them defined at the top of the vagrant file, and then the provisioning, it can just be a bit neater. Excuse me. In this specific example I've done here, this would not require that provisioning flag be added because it has the vagrant command has been given the option to run always, so it's not just running the first time that it's launched. Okay, an alternative to using these, it's effectively shell scripting to to set up our machine, we can use a tool called Ansible. Ansible is a open source community project sponsored by Red Hat. I'm going to go back to full screen here. It is infrastructure as code, or it can be considered as configuration as code. So here it is a domain-specific language to tell it what to install, and depending on what system you're instructing it to operate on, it will find the its own way of doing that. So, for example, I would tell it that I want Vim, but I wouldn't specify that I wanted to use Yum. It would see that it's running on a CentOS bot, on a Debian or a CentOS box, and it would itself install it via Yum, but on a different system. It would use, apt-get or whatever. Ansible is typically agentless. So I would run it on my Windows machine to connect over SSH to manage the virtual machine. There are a number of alternatives. Chef and Puppet are similar, although these are both agent models. So you would actually have to have something running on a client for Chef or Puppet running on the VM. And there's also Terraform, which is typically for provisioning virtual machines, so it's not quite the same. In a Vagrant configuration, this is what it would typically look like. You would give it a YAML playbook, which would describe what it wants on the system, and then it would just see whether the current state of the VM is different from what the playbook describes, and then converge it towards what is described in the playbook. As an example of what a YAML playbook would look like, here is a playbook which ensures that GCC is installed. It uses the text present to see whether it needs to change anything in the state. So if it's present, then it just won't do anything. Ansible can do a lot more than just installing software. You can populate file systems. You can populate them from templates. You can set up Python virtual environments. You can pull down Git repositories and settings. Yeah, there's I've just scratched the surface of what is available in Ansible. There's, if there's something that someone would want to automate, someone's probably written an Ansible playbook for it. Okay, I think that's everything I wanted to cover. And sorry, I haven't left much time. Yeah, so I hand it back to you. Bless.
Thanks very much, Stephen. That was great. If anybody has any questions, then if you could start putting them in the chat, we'll have like a question and answer session after Michael's done his talk. So do you want to pass over to you now, Michael?
Hello, can you all hear me?
Yes, we can.
Good, okay. Let me just share my screen. Make sure I share the right one. That's the one. Okay. Are we all okay on that? I don't like this hovering.
Yeah, we're all good.
Can I make the... Never mind. Okay, so I'll open my slideshow. And this is a quick overview of what I'm going to cover. So I'm going to be building a Docker container using GitHub. Little bit about what containers are. I expect most of you have heard of containers, and probably many of you have actually used them in some way. So I won't say much about that. Then about deployment, the project that I'm going to deploy, and then a little bit about the Docker build process, Docker files and so on, and the mechanism that I'm actually going to use on this occasion is a GitHub action. So everything's going to be done in the cloud. So more on that now. So what are containers? Containers are packaged applications that can be run anywhere Docker is available. Docker containers are usually described as being lightweight, and one consequence of that is that they can be started very quickly. You can build sophisticated web services by orchestrating many containers, and that's often described as the sort of the main use case for these. But on this occasion, I'm just going to build a single container and show sort of the utility that you can get from even just a single container. So there are three aspects to this really when we're working with containers. We've got, as you've just seen with Stephen, with vagrant and so on, that you've got client commands and so on. So we've got some command line stuff that we can do, Docker build, Docker pull, and so on. And then we're talking to a Docker host environment, which is really essentially a virtual machine, but it's a virtual machine that's running many of these isolated containers within it. And then the registry, and I'll say a little bit more about the registry as we go through the talk. Okay, for this example, we're going to build a single container. It's going to contain a Python Flask web server. Now, the source files for this project are hosted on GitHub. And obviously, we're also going to need to have somewhere that we're going to run that container to host our website. And there's a third element to this, which is this container registry. So we've got the kind of a separation of the source code, which we're going to build to create a container. The container registry, which is, again, a cloud service that will host our compiled and ready to run container image. But to actually run the container, we need to have an instance or maybe several instances of that container. So our hosting service will pull the image and then run the container in the hosting service to allow our users access to whatever it is our application does. So we've got three cloud services that we're interacting with to create all of this. Nothing is being done on my laptop or whatever. Everything is happening in the cloud. So as we're going to deploy directly from a Git repository, in GitHub, we need to have everything that is required to define our application. It depends very much on the language that you're working with and so on, but hopefully most of you are familiar with Python. And for Python, it's pretty straightforward, really. It means that we're going to need the Python command itself, pip, and we're going to need the list of requirements of the libraries that we want to, modules that we want to install. We're also going to need a further configuration file, which is our Docker file. So I'll say more about that now. The Docker file describes how to build the container and optionally the command that we want to be run when this container is executed. Docker is programming language agnostic. So although this isn't kind of like a full virtual machine, we're still going to need to specify the language tools we need, in this case, Python and pip, and the libraries. So typically we do this by choosing an appropriate base image. So we don't typically start when we're working with Docker with sort of a basic Ubuntu or other sort of Linux image. We'll start in this case with something that's already got Python installed on it. So the first line you'll see there is for the Python Docker image that we're going to add to. So this first part of the file here, these first 9 lines, 1 to 9, is defining how to build our Python application. And really, it's nothing much more than just copying some files across. So we need to copy files from our host environment, which in this case is our Git repository. So we're going to be on GitHub. It's got access to our repository and it's going to copy things across. So it's going to copy our requirements.txt file in, and the last line you see there, 9, it's copying the contents of our Flask server application across. So anything in that directory will get copied across. And then in the middle there, you can see some Python pip stuff in the usual sort of Unix command style. The last few lines here, so lines 12, 13, 14, that is our suggested command that is run when we when this container is executing. So we're setting up a port number there that we wanted to serve our web server on, and we're going to, that command is made up of 2 words, Python and Flask server. So once we've got our Docker file, it's a configuration file for the Docker build tool. We're not going to typing our stuff on indirectly. So the output you're seeing here is actually coming from GitHub. This is what happens when GitHub is tasked with building the Docker image from the Docker file. And that's achieved by setting up a GitHub action. So GitHub actions are automated workflows that use containers to build, test, or deploy software. And they can be quite simple. So I'm going with fairly basic workflows here. You will sometimes see, very complicated workflows where people will write a whole series of steps, testing and so on, and conditional things in the workflow. You can do it either way. My preference is to actually have a number of separate workflows that do different things. So in this case, this is a workflow that builds a Docker image. It doesn't even save the image. The purpose of this workflow really is just to check that the contents of the repository are capable of building a Docker container image, and the end result of this will be discarded. I'll show you the point of that when I do a little live demo. I said I would say something about the container registry. Container registries are a means of making containers either publicly available. So this is a public repository here, which contains the latest and a series of earlier images that I've created for this particular project. You can also have private registries where you have a secure mechanism by which you can push and pull images to the registry. That allows you to, if you're working with large containerized projects, it means that you can keep your containers secure, but they're easily accessible for both, submitting new versions of containers or pulling them down and using them to build applications. Once we've done all that, deploying a container is incredibly simple. At its most basic, we just tell the hosting service the URL of the image to deploy. So you can see here, there's container image URL. We enter that in, and then that's pretty much it. We can run our container directly on a service such as Google Cloud, AWS, Azure, or there are many others that will do this. And then once it's up and running, you can see here we've got a URL of the that will actually give us access to our running application, and that URL there is actually the one here. So that is the website that I've got there up and running. Okay. So now I'm going to quickly do a live demo on this. We're going to see a GitHub pull request. I said it's already submitted. I'll submit it in a moment. We're going to approve the pull request, create a new release, and see how the GitHub actions build and push the image, and then we'll manually update the deployed version in Google Cloud. Now, I say here, typically that last step is also automated. And there'd also be other automation. If you're working with a really true DevOps style of continuous integration and deployment, you wouldn't be pushing images up to your registry, that you hadn't tested in some way to be sure that they were good to use. Okay, here we go. So I've opened a pull request. I've got some slight changes I want to make to the website. So I've just made a comment there. If the container build is good, then this can be the next release. So there we go. Create the pull request. And what you see now is that we've got a test that started running. So we've got here some checks haven't completed yet. And it's actually running a test. It's not really a test. It's that that build of the Docker container. So if I go to actions here in GitHub, I can see here that I've got my Docker image test build is running and it's just passed. So I can click on here. I could have clicked while it was still running. I was a little bit slow, and that's telling me green tick, it's built. If I click on here, I can actually see the output from that GitHub action, and I can expand on these and see the various things that are done. Probably the more interesting one there is building the Docker image, and we can see there quite a lot of output from Docker build, and we can see that it's succeeded. So if anything goes wrong, that's where you'd see it. Right. Sorry about the phone ringing. That will stop in a moment. Right. Okay. So we've done a pull request, and if I go back to that now, all our tests have passed. So we're going to accept the pull request. And that's now going to merge into main. Okay. So we've got a new version of the code in GitHub in our main branch. And what's happening here again is that that test that we've just seen is being run again. That's because in the action, I can show you that here in the workflow. In this test build, I've got these conditions, and I'm saying that I'm going to run this action when there are pull requests and also when there are pushes to main. So the idea here is to ensure that main is always in a good state, and we know if anything has upset our build so that we can't deploy. Okay, but we know it's good. So what we want to do now is release it. And we're going to release it by selecting releases here in GitHub. And I'm going to draft a new release. Choose a tag, and I'm going to go with a new tag, v0. I'm going to stay on 01. So we'll go there, create a new tag. Typically, I just name them in the same way. And put a comment in, set this as latest release, publish release. And that's done. We have a new release in GitHub. What this will now trigger is further actions. And I've got two actions now running in parallel. One of the actions, which we're going to ignore for now, is creating a new container image and pushing it to the GitHub container registry. And it's also going to be building and pushing to the Docker Hub container registry. If I click on there, I can see this build is in progress. Again, it's finished before I've had a chance to look at it, but everything has worked fine, and it's pushed that up. Where did it go? Login, post build. So there we go. It's cleaned up. Everything's fine. Okay. So that should mean we've got a new version. So let's have a look in Docker Hub. And if I look in Docker Hub and refresh this page, there we go. A minute ago, version 1.0.14 has been pushed to the repository, and that's available to use. If I go into Google Cloud, I can see my dashboard here. I'm going to go to Cloud Run. So a service I'm using for running this particular container is Google Cloud Run. I've got a couple of instances of this running already. I can either update one of those with the new image. So, or I can create a new one. Let's just create a new one. So this is what you would do if you're creating a new one. Create a service. And it's asking me for the container image URL. So if I go here, in fact, I'll go with this one here. So that's our container image. Now, unfortunately, most of the cloud hosting services now, AWS, Google, and so on, kind of default to their own container registry. So we need to, I think we need to be explicit in there and say that we want to use Docker to source our image. And I can give it a name. Pick a region. I don't know why. I tend to think that it's probably better to put them somewhere in Europe. I'm going to scale. I'm going to put a maximum number of instances down to a sort of a more realistic number for the kind of things that we're doing. And here I need to select allow unauthenticated invocations because we're creating a public website. And then create. And away it goes. And it's done. So if I open that link here, we can see if I go back to the original website that I started from at the beginning of this talk, it said release 0.13, and in the new version here, we have 0.14, and I've changed the title slightly so it says RSE South webinar. So that's done. I see what I could say there is obviously if I wanted to do a new release on there, there's even less to do. If I click on here, edit and deploy new revision, all I need to do is change the version of the container image in there and hit deploy, and that will update with the latest image. Okay. So like I said in here, that last step is typically also automated, but I wanted to show how simple that was, and hopefully you got an idea of how straightforward the other stages are as well. You know, anything like this where you're automating, it's going to be lots of small pieces. You don't want to put one big script that does everything. So that's what we've just done. We've built on GitHub. So on GitHub, we used a GitHub action to create our Docker image. We pushed that to Docker Hub, and then we're able to pull from Docker Hub to the hosting service. These days, all of the hosting services want to get in on this game. They've all got the facility to build Docker images within their cloud service. So quite often what you do is you'll just have your repository in GitHub, and so long as there's a Docker file there, your hosting service, Google, AWS, and whatever, will be able to pull the files down, build a Docker image. They'll push it into their own container registry typically, and you may have to pay for that storage and so on. It's not going to be expensive, but they'll provide that for you, and then they'll update the container that's running automatically. So you can do it, and that would be probably how I would typically do it, would be just using those two services. But it's nice to be able to see the detail of what's actually happening at these different stages. So I broke it down a little bit. What next? I'll let everyone decide if they want to do anything with containers and whatever. Take your own journey. Something I quite like to do at the moment is using Google Cloud Shell. If I go back to Google here, there's this little button up there, activate Cloud Shell. If you're a Linux user or whatever, it's all very familiar. It's all there. Docker is set up so you can do Docker pull, Docker push, all of that sort of thing. And you can even run Docker images. If you set your output port at 8080, you can actually click on this little web preview button here, and that will preview your Docker container. So you can actually do the whole thing I've just done there. You've even got Git, so you could, on the command line, you could pull down from Git, build your container, do everything here. Great if you've got bugs. If things aren't working right, you can sort of break it down and do it by hand in there. Containers as development environments, that's becoming quite popular now. Visual Studio Code has got some great support for containers, so you can actually create development environments inside containers or virtual machines, connect your Visual Studio Code instance in as though it's kind of like a remote development environment. And it's handy if you want to create sort of throwaway environments for working in a language that you perhaps don't use all the time, or you want to preserve it. You want to keep that development environment fixed in some way and not have it upset by upgrades and so on. And then if you're really getting into using containers and you want to have these kind of like multi-container applications, then you're going to need to look into Docker Compose and Kubernetes. And that's the end. And if I click on there, it will take me back to the place I started. Okay, thank you all for your time, and I hope you found some aspects of that interesting and that you maybe can make some use of that in your own work.
Thanks very much, Michael. That was great. So I'm a little wary of time, but we've got a few questions in the chat. If anyone else wants to ask a question, then please do. Stephen, I think this one's for you. So how do you specify RAM, CPU cores, and storage in the VM created by Vagrant, or is that predefined in the box?
Yes, so you can find the options for that, for how to change it in the Vagrant file, in the Vagrant documentation. So the commands might be slightly different across the providers. So here, the provider that I was using, that was VirtualBox, Oracle VM VirtualBox. And if I just share my screen a second. So here I'm just in the documentation from Vagrant, and there's a provider section, and VirtualBox configuration has this for specifying the number of CPUs and the amount of memory. So yeah, and there is an example within the base template, which at least specifies the number of memory for the VirtualBox provider. So yeah.
Great, thank you. We've got another question, which I think is for Stephen. So what are the main pros, cons of Vagrant versus Docker?
Yeah, I Personally, I was using this VM and I quite liked the simplicity of just these quite few vagrant commands to get it up and running. And that was working well for me, although I am aware that if you start to put a bit more provisioning in, then you can have, it can start to take minutes, tens of minutes to actually provision the VMs. And if you have something equivalent in Docker, then it can take, tens of seconds. So there is kind of a limit to that sort of benefit. But yeah, I find I like the simplicity. I like the ability to just change the memory and the number of CPUs. I've not played around with Docker and with multiple CPUs that much, but
Great, thank you. And Michael, one for you. So Docker Compose volumes allow for application configuration files to be mounted into Docker containers. Just wondering if Google Cloud allows for application configuration files to be mounted.
I'm sure it does. I chose to use Google Cloud Run for this particular demonstration because it's a very simple way of running a single container. Docker Compose is really more about multi-container images and other services and connecting them together. And there are different sort of hosting environments for that. What I would say, and can I just share my screen again? If I just share. One of the nice things with this Cloud Run service is we can actually see a lot of diagnostics around startup latency. So, how many milliseconds it's taking to start up containers, memory utilization and things like that. And Cloud Run scales down to 0. And what that means is that we will actually not run any containers at all unless there's a request, obviously. So that startup latency matters. The fact that it can start a container in less than a second is kind of important, because your users of your website won't notice that the container started when they made their request. It also means, in terms of billing and also the impact on the environment, is significantly reduced. Obviously, I've just been putting this together for demonstrating. I've got a couple of other websites that I make use of using this technique. My Google bill per month is at the moment less than 10 pence a month. It's using pennies, and in some days it's not using anything at all.
Thank you, Michael. There's lots of good discussion in the chat, which is great. I don't think I've seen any other questions unless I've missed one. But we're nearly at the end now. So what I'm going to do is thank our speakers, Stephen and Michael. Thank you very much. And thank everyone for joining. As this has been recorded, we will post it at some point. We're not sure where we're going to post it yet, but we'll let you know, and we'll keep you updated on when we're going to have another one of these. So thanks very much for joining, and hope to see you all soon.